Hey guys, Nathan here from the Paramedic Preload. Today I wanted to start the process of doing some quick videos for you guys on medication math and kind of working through the different types of formulas that we use and kind of demystify it. A lot of people are really scared when it comes to medication math and they're afraid they can't figure it out. And in reality, the truth is there's some very simple formulas that we can use. And when we use those simple formulas, it allows us to quickly get our answers. And it's not as scary as what a lot of people think. So we're going to start off with a couple simple ideas that are based as far as medication math is based on. And one of those is here in America, we always like to use pounds as our weight. And there's a lot of weight-based drugs that we use in EMS. Now, it's a pretty simple conversion to get it over to kilograms, but if you haven't done it in a while or you just don't remember or you've never been told, it's essentially what we're doing is we're dividing pounds by kilograms. And so what we do is I'm going to put up a very simple one for you real quick. Let's say we have a 220 pound patient and we need to convert that to kilograms. So what do? We're going to divide the 220 by 2.2. And if you do in your calculator 220 divided by 2.2, what it's going to come up with is it's going to equal 100. And so what that is that's a patient's weight in kilograms. Now, of course, this gets a little bit more difficult as we get away from kind of those perfect whole numbers. And a lot of times these are guesstimates. Sometimes the family knows, but let's say the patient weighs 75 pounds. And so now you have a pediatric patient, which is, a pediatric patient we can come across. And so we get 75 pounds and we need to convert that into kilograms. So how do we know how many kilograms that is? Well, we divide that by 2.2. And so 75 divided by 2.2 is going to equal 34. And technically speaking, it is 34.09. Now, if I was taking a test or I was, working, if I was working through some math problems more on paper, I would leave that 34.09. Let's just be honest, when you get out in the field, that 34 is what you're going to run with. It's close enough for us to be able to get there. It's, optimal to keep those numbers in there the whole entire time. But then when you end up with kind of a weird like 0.145, okay, well, I can't really get that. So you can't be that precise, and so we know that that's going to get rounded a little bit. So no worries there, but if you are doing it for paper tests, leave your decimal place and at least give, 2 after that decimal there to help you with your number itself. So let's talk about another concept that goes with this. We are going to be talking about cc's and ml's, and this is going to be volumes. So whenever you hear volumes, you're going to see cc's or ml's. And whenever we say cc, cubic centimeters, or ml's, just know that they are interchangeable. So you can use ml, you can use cc, you can use ml/cc, you can use cc/ml. It doesn't matter. It's however you want to write that, however you kind of want to put that interpretation over, but essentially mLs and cc's are used interchangeably when you are looking between cubic centimeters and milliliters. Also, another concept is we're going to be doing a lot of conversions, and not necessarily for the bolus, which I'll talk about here in a second, that we're going to talk about today, but when we get into the drips. When we get into those drips, you're going to start noticing things like micrograms and milligrams and grams. And so an important concept for us is just to understand, and this is just a given, so it's pretty easy to memorize, but it takes 1,000 micrograms, mcgs, to equal 1 milligram. We have 1,000 milligrams to equal 1 gram. And then Grams itself, that is kind of the largest that we deal with. We don't get beyond that, so you don't really have to convert that one. Essentially, you're going to be converting grams back to milligrams or milligrams back to micrograms and making them smaller as we're trying to get our numbers. And so as we move forward, you're going to start to see some of these come out. Now, here's also the formula that we're going to be using, and you're going to see it on every slide that I give you. But essentially, for a bolus. Now, quickly, what is a bolus? A bolus is a medication that you're going to give as kind of a one-time. It's not given over a drip. It's not given through a piggyback. It's not given through a saline line or anything like that. What it's given through your syringe. So you're going to be pushing this. Now, you may push it into your line, your IV line, but you're not going to be hooking this thing up and doing this, this type of drip set or putting it into a pump. You may push it through that line and then flush it through after that, and that's totally fine. But this is different. This is a one-time medication bolus that we give. And so that's what we're going to be talking about. So what's our formula for that? It's a pretty simple formula. It's going to be volume to be administered. I always, just to keep it on the page, use my abbreviation. So volume to be administered. And that is going to be volume on hand times desired dose. And that's going to be divided by our dose on hand. So write that down because we are going to need that here shortly, and I will continue to write it as we go. Write it every time. The more times you write this, the more it's going to stick inside your head. It's really going to stand out to you and start to just ingrain in your head, and then you won't have problems with this. So let's talk about where do we get those numbers. All right, so here we have a vial of diphenhydramine, also known as Benadryl. This is the really cool IV paramedic stuff, right? You get to give this stuff, or you get to give it IM, intermuscular. And so we're going to use a formula to try to figure this out. Now, the first one I'm going to try to do very simple. Remember, these are one-time boluses, and so that is the formula that we're using. And so when we talk about this, let's write out this formula real quick. So let's go with volume to be administered. And sorry, that was a mistake. There we go. Equals volume on hand times desired dose over what is our dose on hand. Okay, so where do we find these numbers? Well, if we look at this vial that's up here in that top left corner for you, you guys can see it says it's diphenhydramine. It's 50 milligrams per ml, and it's a high potency. And then just below that, kind of hidden right here, take a look, it's kind of hidden, 1 ml vial. So what is that telling us? It's telling us that we have 1 whole milliliter of volume inside that vial. So remember, volume is going to be cc's or mLs, however they put it. If you look at the number just underneath the diphenhydramine HCI injection, it says 50 milligrams per ml. So that's going to help us get some of our numbers. So what is our volume on hand? Well, our volume on hand, I'm going to draw an arrow to it. The total volume that we have on hand, it's a 1 ml vial, which means we have 1 ml in there. So if we do volume on hand, let's punch in 1 ml. We're going to figure out our desired dose here in a second. And then what is our dose on hand? Well, our dose on hand is this right here, which tells us we have 50 milligrams per ml. Well, if we have 50 milligrams per ml and there's only 1 ml in there, guess what? Dose on hand is going to be 50. So let's put a 50 down there. Now, desired dose. Let's go simple for the first one. Let's say our protocol says that we're going to give this IV, and usually IV, it's going to be, let's say it's usually 25 to 50 milligrams. So let's go with the 25. We're going to go with the lower dose of Benadryl on this one. So let's punch in 25 here. So our desired dose is what our protocol asked for, which is going to be 25 milligrams. So if we do kind of the math here, now you can cross cancel if you want. If you want to be a purist and kind of say, hey, we've got to get rid of everything on there. We've got to do it right. You can take your microgram or your milligrams, I apologize, and you can cross those out, which only leaves you with mLs, which makes sense because we're looking for volume to be administered. Or you can just punch in your math and know that the answer it gives you is going to be volume to be administered. So if we do 25 times 1 ml, to break it down, that's just going to simply be 25. We carry that ml over if you want, and that's going to be over 50. And so if we do 25 divided by 50, that is going to equal 0.5 mLs, which means that if we give 0.5 milliliters, or half of that vial right here, if we give half of that vial, then we are going to get the desired dose of 25 milligrams for our patient going through this, allergy issue that they have in the current moment. And so that gives you, volume to be administered equals 0.5 mLs. Now, the reason that I put a 0 in front of it, I know a lot of people will say, it's kind of, let's just add an extra stuff you have to write. But on a document when you're writing, you don't want them to mistake that decimal point for a period from the sentence that's just before that number. And so if you do just a 0.5 and you get a space in there on accident, or it doesn't show as well on their document, somebody can interpret that as I need to give 5 mLs. If you give 5 mLs, you are going to be giving a ridiculous amount of Benadryl and you are going to be way over your protocol. So let's not do that. That is a horrible idea, and let's try to stay away from that best as possible. Make sure that you put a 0 in front of it so that way it does not get misinterpreted. So let's take this a little bit further and let's do this as a pediatric dose. Now, protocols usually for pediatrics, for diphenhydramine or for Benadryl, let's just say they go with the 12.5 milligrams, which I've seen before. And so we'll say they go at 12.5, which is going to break it down just a little bit further. And so what we're looking for is now we're trying to make this a much smaller dose. So let's put our formula back in and let's do our volume to be administered is going to equal, so our volume on hand times desired dose over dose on hand. And remember, the more you write this, the more it's going to be ingrained. So we're looking for volume to be administered. So let's punch in our numbers again. Nothing's changed. This is the same vial. This is the same formula. We're still in our bolus formula. So what's our volume on hand? Well, we talked about that earlier, right? It's a 1 ml vial. So that is going to be volume on hand is going to be 1 ml times our desired dose. Now our desired dose is 12.5 milligrams. And what's our dose on hand? Well, our dose on hand has not changed. Once again, it's coming from up here. It's 50 per ml. So what do we have? We have a total of 50 milligrams because there's only 1 ml in the whole entire vial. Now, we can do our math and say, okay, 12.5 times 1. Well, 12.5 times 1 is 12.5. And put that over 50. And if we divide 12.5, so if we put that in our calculator, 12.5, and we divide by 50, that is going to equal volume to be administered equals 0.25. So if we give 0.25 milliliters, then we have given the pediatric dose of 12.5 milligrams is what that equals. And so we have given that at that current point, and we have now given the patient the desired dose or the protocol dose of the Benadryl that they should be getting. Now let's move on to another med that we give out there a lot. This is Narcan, right? Naloxone, as you can see it. And it does come in all different shapes and sizes, depends on who they order from or where they order from. So don't ever be deterred when you grab something and it's the wrong, or it's a different color. I shouldn't say the wrong color, because that's how it's manufactured, is that color. But sometimes they're orange tops, sometimes they're green boxes. So it's going to change. But look at the brand name on there. Just know what your company carries, or whoever you work for, your agency carries. And then you're going to essentially just punch in this bolus formula and we're going to make it work. Now, we're going to make this one a little bit harder because one of the things with Narcan is per protocols can be given 0.4 to 2 milligrams for these patients. So let's say that our protocol calls for 0.4 milligrams of this. Okay, let's punch this in. Let's see how we can do this. So volume to be administered is going to equal volume on hand times desired dose over dose on hand. So let's go find these numbers real quick. So what's our volume on hand? Well, how much do we have in here? Now, this one's really cool because it's got this little tiny circle and it gives you all the information in this little tiny circle. Do not be confused with a number that's right here. And I'm going to draw a line underneath it. That big old thick line I just drew, it says 1 milligram per 1 ml. That is fantastic information because that tells us what the concentration is. But I'm not asking for a concentration in the current moment. What I'm asking is how much volume do I have on hand? Well, if you look right above this, volume on hand, there's that bubble and it says there's 2 milligrams per 2 mLs. So what that means is we have 2 total milliliters inside this whole entire vial. So let's put this in our formula. Volume on hand, 2 mLs. What's our desired dose? Well, we just worked that out. Desired dose is our protocol dose. So times 0.4 milligrams over our dose on hand. Well, what's our dose that we have on hand? How much total medication do we have? We have 1 milligram per ml. We talked about that in concentration, but we have 2 mLs. So if you look at that bubble again, I'm going to draw an arrow that goes all the way up and around to it. We have 2 milligrams total as far as dose on hand. So dose on hand, 2 milligrams. Now, all we have to do from here is we just plug this into our formula. If you do the 2 times 0.4, that is going to equal 0.8, and we're going to divide that by 2. And that equals, how much should we give? Well, we should give volume to be administered should equal 0.4 mLs. So if I give 0.4 mLs of Narcan, I have given my protocol dose of 0.4 milligrams. Now, let's kind of take this a little bit further. Let's change this. We know where we're getting our numbers from. I want to change this to 6 milligrams. I want to throw this off a little bit because what happens if you're like, hey, you know what? I don't think 0.4 is going to do it. I think it's going to take 0.6. So I'm going to switch out my numbers really quick. So numbers all come from the same spot, right? Volume on hand is 2 mLs. And then our dose on hand is going to be 6 milligrams, or I'm sorry, 0.6 milligrams, apologize. And then our dose on hand is going to be 2 milligrams that we have total. So nothing changes, same box. I just changed my dose. So if you do that 2 times 0.6, that equals 1.2. And if we have 1.2 and we divide that by 2, that is going to equal volume to be administered will equal 0.6. So if we give 0.6 on that, then we have given our protocol dose. Now, I know that those numbers, you're like, oh, those numbers just match. But if our concentrations are different, then it's not going to match in that sort. So this is where I tell you guys, go grab some of these medications out of your kit that you, in the places that you work, and run through these math problems. Go online and search a medication and find a vial. They're all over the internet. Go find a vial of Versed on the internet, or of Benadryl on the internet, or find a box of atropine or something like that, and just run through these problems and just constantly go through these and continue to do these med math problems. Now, let's kind of round this bolus medication back up with one last one. And I'm going to kind of throw this one, I'm going to throw a little wrench in this one. We are going to say that you are running a pediatric cardiac arrest. and you need to decipher how much to give. Now, I will tell you that your protocol says that you should be giving, pardon me, 0.01 milligrams per kilogram. So that's what our protocol says. Now, you notice something. It doesn't just say milligrams, it says milligrams per kilogram. Well, I'm going to tell you that this patient is 32 pounds. Let's go with 32 pounds. And I know that's not fair, right? Because, well, if you give it to me in kilograms, I wouldn't have to do more math. But let's do 32 pounds and let's divide that 32 pounds by 2.2. And what you should get is your kilograms, which would be 14.54 kilograms. So for the sake of doing math in front of everyone, what I'm going to do is I'm going to continue using the 14.54 throughout, and then we'll talk about the number and the outcome when we get to it here and how do we do this in the field versus on paper. Now, our protocol says we need to give 0.01 milligrams per kilogram. And we know that this patient weighs 14.54 kilograms. So if you're not into just moving decimal places, let's make this super simple. We are going to do 0.01 times 14.54. And if you've done that math, that is going to equal 0.145. And that's going to be the number we run with. So protocol says we should give 0.145 milligrams to our patient. So let's punch in that formula real quick. So volume to be administered, still looking for volume, times volume on hand, times desired dose. And then we're going to put that over our dose on hand. Okay, so let's do some math. Let's have some fun with this. This is going to be an easy one to figure out here. This one also has that big old bubble. Remember, concentration is under the name on this box right here. So that's our concentration is 0.1 milligrams per ml. But how much volume do we totally have on hand? Well, we know volume has to be in mLs or cc's, and I see 10 right here. And it says that we have a total of 10 mLs on hand. And we're going to put that times our desired dose, which is 0.145. And we're going to put that over our dose on hand. Well, how many milligrams are inside this whole entire preload? Well, inside this whole entire preload is 1 milligram. Look at that right above that 10 right there. We'll draw that down. We'll make that connect. And so we will put 1 milligram there. So let's do our math real quick. Well, if you take 10 and you times that by 0.145, that's going to equal 1.45. And if you're into moving decimal points and you're good with that, that's totally cool. I'm just trying to teach this step by step for everyone. And we're going to put that over 1. Well, anything divided by 1 is going to be the same, right? So you can put that in your calculator if you want, but in reality, anything divided by 1 is going to be the same. So in total, volume to be administered is going to equal 1.45. And remember, it's volume, so it's going to either be cc's or mLs. So out of this preload, if you give 1.45 mLs or cc's, then you are going to get your desired dose, which would be 0.145 milligrams for your 32 pound or 14.54 kilogram patient. Now, the one thing about this is it's going to be very, very hard to get exactly 1.45 mLs. We just have to be honest about that. So you're going to try to just get as close as you can. And this is where it kind of turns into sometimes a rounding, where you may give 1.4. You may give kind of the middle between 1.4 and 1.5, but you're never going to be exactly precise at 1.45 mLs. So just know you're going to do your best to get within that area. But precision is a very, very hard thing, especially when you're looking at ampules like this. Even if you're dealing with some of the smaller syringes, sometimes they're even just as hard to get precise into those weird numbers. And so just know that you're going to round and you're going to come to your nearest number and you're going to try to get as close as you can. Now that closes out the video for our bolus medications, and I have more coming for IV drip over time, and dopamine drip. I appreciate you spending your time with me and looking through this. I hope this really helps. Play it back multiple times if you need to. Leave a comment if you have any questions. More than happy to try to comment back as soon as we see that, so that we can help you get through this. I just gave you a few examples. I encourage you to go out, take these formulas and use these as you are looking at medications. The cool part about this is it works with any medication out there that you're giving as a bolus. You just have to be able to find the numbers and plug in the numbers as I'm helping you here on the box or on the vials. So have a great day, and we'll see you on the next one.